All right, let's dive right in. Today, we're taking a journey to understand one of the universe's greatest and maybe most terrifying mysteries, the black hole. We're going to figure out how they're born, how they work, and what really makes them the ultimate cosmic monsters.
And that quote, it just nails it, right? We are heading into territory where our entire understanding of reality gets pushed to its absolute limit, a place of true cosmic extremes.
So right off the bat, let's get one thing straight. A black hole is not a hole at all. It's actually the complete opposite. It's an unbelievable amount of matter, of stuff, crushed into a space so tiny it's almost impossible to even imagine. That density, that's the key.
Okay, so where do these monsters actually come from? Well, they aren't just born, they are kind of like the ghosts of ancient, absolutely massive stars. So let's witness their spectacular and violent creation.
You know, for billions of years, a massive star is locked in this perfectly balanced cosmic tug-of-war. On one side, you have gravity, relentlessly trying to crush it inward. And on the other, you have the nuclear fusion in its core, creating these massive explosions pushing outwards. It's a stalemate that pretty much defines the star's entire life. But what happens when that fuel runs out? Well, that outward push just stops. And gravity wins. Instantly. The star's core collapses in a fraction of a second. The outer layers rebound in this brilliant explosion we call a supernova. And what's left of that core? It just keeps crushing and crushing and crushing until a black hole is born.
All right, so a brand new black hole exists. Now, if we could park our spaceship let's say a very safe distance away, what would we actually see? Let's break down its anatomy.
We're going to look at 4 key parts that make up a black hole in its really chaotic neighborhood. And trust me, each one is more mind-bending than the last.
Right at the very heart of it all, you have the singularity. Now, this isn't really a place. It's more of a condition. It's all the mass of a dead star, squashed into a point with literally zero volume. Here, the density is infinite, and all our laws of physics, they just stop working. Next up is the event horizon. Think of this as the ultimate border crossing. It isn't a physical wall or anything you could touch. It's an invisible threshold, a point of no return. Once you cross it, the speed you'd need to escape is faster than the speed of light, and since nothing can travel that fast, there is no coming back. Ever.
So wait a minute, if black holes are invisible, how do we see them? Well, we see this, the accretion disk. It's this chaotic, glowing halo of superheated gas and dust that's being pulled in. This material swirls around so incredibly fast that friction makes it glow brighter than entire galaxies. This is basically the black hole's dinner plate.
And you know what? Sometimes black holes are really messy eaters. When they try to consume too much, too fast, these powerful magnetic fields can grab some of that material and launch it away from the poles in these incredible jets. They're like cosmic blowtorches, blasting pure energy across millions of light years of space.
So, we've seen the parts, but how does it all actually work? Why is the gravity so unbelievably intense? For that, we need to bring in the big guy, Albert Einstein, and talk about the very fabric of the universe itself.
Einstein had this absolutely brilliant idea that space and time aren't two separate things. Nope, they're woven together into a single, flexible fabric called spacetime. The easiest way to picture it, just imagine a giant cosmic trampoline. Okay, so you have this trampoline. Now place a bowling ball in the middle. See how it creates a dip, a curve in the fabric? That curve is what we experience as gravity. Planets orbit the sun because they're essentially rolling around the deep curve the sun creates in spacetime.
So, what does a black hole do to this cosmic fabric? It doesn't just create a dip. Oh no. It's so dense, so extreme, that it punctures an infinitely deep funnel right through it. The slope is so steep that once you get too close, there's no direction to go but down. And just to give you a sense of the sheer mind-boggling density we're talking about, get this, to turn our entire planet Earth into a black hole, you would have to compress all of its oceans, its mountains, everything, down to the size of a single peanut. We've seen how they're born, we've seen how they work, but now for the question everybody always asks, what would actually happen if you fell into one? Let's take the ultimate plunge.
Your journey would end with something scientists call, and I promise you, I am not making this up, spaghettification. The gravity pulling on your feet would be so much stronger than the gravity on your head that it would literally stretch you, pulling you apart into a long, thin stream of atoms. But here's where things get really, truly weird. From your perspective, the fall into darkness would be quick, maybe just a blink of an eye. But for your friend, watching from a safe distance, something totally different happens. Because gravity bends time itself, they would see you slow down as you got closer, seem to freeze right at the event horizon, and then slowly, over an eternity, just fade away. For the rest of the universe, your time just stops.
Okay, let's pull back from that terrifying thought for a second. Because as strange and as scary as they are, black holes are not just cosmic curiosities, they are absolutely fundamental to how our universe is built.
They generally come in two main flavors. You've got your stellar mass black holes, born from a single dying star. And then you have the supermassive ones, the true kings. These things are millions or even billions of times heavier than our sun, and we found one at the heart of almost every single galaxy, including our own Milky Way.
So here's the really crucial thing to take away from all this. Black holes aren't just destroyers. They are galactic engines. Their immense gravity helps hold entire galaxies together, and the crazy amount of energy they blast out helps regulate the birth of new stars. They're a vital part of the whole cosmic ecosystem.
So, in the end, they aren't the villains of the cosmic story. They're more like the architects. They build and shape the universe as we know it. And that just makes you wonder, right? What other secrets are they hiding down there in that abyss? What else are we waiting to discover about these incredible cosmic engines?